evening, everybody. Welcome to Saturday Night Rabbit Hole. It's November 30, and yes, we're still in California. Well, we finished our uh, California earthquake discussion here. Another overview, nothing too substantial, just kind of giving you an overview of the earthquakes from September 1st to November. Oh, I think it was probably like 26 or whatever that week, that's last Saturday was, the 23rd. So, um, plenty of great information there for you. It's over there on Rumble. Just look up Joe Slick Live, and or you can just look up the Rabbit Hole, I believe. If I went to the Rabbit Hole, right? I don't know. I'll find it for you. Um, for those on Twitch, I'll make sure that you have a link to those. And dun, 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 dun. Yeah, here we go. Hey, did we do? Oh, this is already on right now. Okay, cool. I don't know me. What do we do here? All. Yeah. Let me see videos right there. Yeah. I don't know. Oh, the channel. My channels. Dilemma. I think you're able to. Why don't you test this for me? Cannot see if you can test. I put the link in there for you. In your chat. I mean, in your whisper. See if that finds the.
Yeah, it works.
All right, cool.
It's even coming up with the live one right
now. The live one's even right now. Yeah. Here you go, everybody. That's the rabbit hole over there on Rumble. It's an easier format, and they don't. If we say something wrong, I don't know that we do. If we say something that's, it's freedom of speech over there, unlike the other venues that we post to. So they might get butthurt, and we don't need any butthurt people. So tonight we're going to talk about California volcanoes, but first we're going to start in Mexico. There's a couple little volcanoes that kind of tie into Salt Butts down there in California, and we want to be able to share that with you as well. And there's my document here. And what else? Also, I think we want to kind of define what the different kinds of volcanoes there are. Because everybody, when you say volcano, they think of stratovolcano, don't they, Canuck?
Yeah.
They's like, well, volcano. Well, that don't look like a volcano, And I think we're going to talk, I don't know, about 13 volcanoes here in California. We're going to talk about those, but defining what a volcano is pretty important too. We use NPS.gov, which is under the volcanoes. We also use the USGS, California Volcano Observatory, and we use WOVO, World Organization of Volcano Observatories, as well. There are a lot of great resources on volcanoes. Lux.collections.yale.edu, California Volcano Observatory 2012 to present. That's another tool we use. We use ssc.ca.gov /disasters/volcano for California volcano information as well. Um, there's a lot of links in there that you can get your information from. Also from the USGS maps, arcgis.com. That's usgs.maps.arcgis. It's arcgis.com /apps/map journal. And you look up the California volcanoes there too. We're going to spend some time in that, beginning with the most southern of the volcanoes, southern Salton Butts or Buttes. And what else? We use the wiki, also volcano updates from usgs.gov, talking about volcano updates and notifications and the like. What else? But for most people, they don't really know what a volcano is. There are many types of volcanoes, and some of those include cinder cones, composition or composite volcanoes, shield volcanoes, calderas, lava domes, and supervolcanoes. Other types of volcanoes include Mars and tuff rings and fissure volcanoes and monogenetic volcanic fields. So we're going to try and decipher all those and tell you what each one, when we go through, what they are and what they kind of look like, so that you as a listener, for the first time, may be able to um, uh, try to extrapolate on what it kind of looks like. Most people look at the stratovolcanoes and go, "Hey, I know what that is." Um, but again, there are different kinds of volcanoes. There's different kinds of eruptions. There's Vulcanian eruptions. There's Plinian eruptions. There's Pelean eruptions. There's Strombolian eruptions, Hawaiian eruptions, and Icelandic eruptions. There's different kinds, and they all kind of sound and kind of act. There's Phreatic eruptions. Yeah, I don't know if I called it that one, but uh, so there are different kinds of things like that will bring about, you know, they define them differently. That's what I'm trying to get at. Scientists do. When I say they, I mean scientists. Um, and the main one you're looking at is a stratovolcano. That's the one that looks like a big teepee with a hole in the top. Shield volcanoes are super big, and fissures is what you see out there in Iceland and I think over in Hawaii too. But I think Mauna Loa is a shield volcano, isn't it? I think it's one of them. There's dome volcanoes as well, and anyway, just uh, just know that there are multiple types, you know, and we'll try to explain those as we go along. Um, it, yeah, volcanoes happen different reasons too. So some are due to subduction areas, some are due in the middle ocean ridges, some are um, like Yellowstone is. That's not subduction and that's not an ocean ridge. That's a hot spot, so to speak. It's where magma's coming up from below the plate, coming up to the surface. So there's different kinds of reasons why volcanoes exist. And with that being said, I think I'll uh, let Canuck start with. We gonna start there in Mexico, or where are we gonna start, bud?
Yeah, we may as well do Cerro Prieto first,
All right, bud.
and then we'll come across and
All right. So
maybe
I'm gonna
go.
go ahead and try to use GE and point to where we're talking about, um, and then let you guys see it. And let me see, view layers. I'm going to shut off all my other layers. Um, and volcanoes. Yeah, I wonder. Yep, is part of that. I don't know what that is. Yeah, I have a list of volcanoes here in the West, or across the world actually. So let me zoom in to Sierra Preto, which I have on screen. So let me share this screen with you. Window right there. Alrighty. Alrighty. So go right ahead and tell us about this little funny volcano that's right here. Is a little tiny thing just below the California border in Mexico.
Yeah.
Called
So I'm just going to read the wiki because it's pretty short.
All right.
Yep. So Cerro Prieto is a volcano located approximately 29 kilometers, 18 miles southeast of Mexicali in the Mexican state of Baja California. The volcano lies beside a spreading center associated with the East Pacific Rise. This spreading center is also responsible for a large geothermal field, which has been harnessed to generate electric power by the Cerro Prieto Geothermal Power Station. The Cerro Prieto Spreading Center intersects the southern end of the Imperial Fault and the northern end of the Cerro Prieto Fault. Both of these are transform faults in the northern leg of the East Pacific Rise system and runs the length of the Gulf of California and is steadily rifting the Baja California Peninsula away from the mainland of Mexico. So we had already talked about the faults before when we were doing the faults down there. So this is kind of like in the middle of them.
Right.
So it's kind of interesting. And also the big geothermal plant that is there, because I've read all about it. It used to be the biggest one in the world, but
Right.
now Clear Lake is bigger. So we'll be talking about Clear Lake later.
Right here. Yeah, I mean it takes up all this area. Um, and how does a geothermal power plant work with a volcano? Can I?
Well, it takes the water and they heat it up, and then it runs the turbines. That's basically what they're doing with it. And down there they have like gigantic water ponds, because you can see them on Google Earth. It looks totally different from how Clear Lake is.
Right.
Because Clear Lake is using more sewage water to do their thing.
Right. They're pumping wet poop down in the ground and doing that. The geothermal plant um, in Mexico here in Sierra Preto, it's huge, and it's a little bit different. They have a different usage. They've got, like, you can see these vents here, right? These big vents where I guess the steam is.
It says it's 820 megawatts right now.
You can see the steam rolling out of this, and I guess that's how they see how one of these things here, the steam would roll out of here and turn the turbine there. They have a different type of system than up in northern Cal at Clear Lake.
And there's 5 power stations at Cerro Prieto.
Yeah, I'm looking at a freaking huge one. Now I don't know if it just by zooming in, if I can spot where the pipes would go and see there. Yeah, they don't show. But here's the water table, right? And so they drill into the ground, pump it into the ground, and there is some solar panels out here too in this setup. and old ancient, ancient meaning old uh, vats where they put the water and stuff, um, treated water or whatever. But yeah, they have a completely different setup altogether. Their turbines are like, here's another one that's smoking right here, or steam rising up. Um, and I think that's the excess that happens as the pressure comes in, turns the turbine, and then pumps out. I'm guessing this is where they go into the ground and the steam pops out because you can see the power lines up here. Yeah. I don't know exactly where they're um, pumping this stuff in on where it goes. But yeah, they have a completely different system than what's happening up in Cali. So this volcano here um, isn't associated, but it's very close to. It's about what did I say, 100 and some miles from Pinacate volcanic field, which is off to the right. And these are relatively young. You can see them; they're all black. The largest of these is Volcano Elegante and Colorado, Sierra Colorado, and there's one other one. Um, um, there's the Pinnacle. Maybe it's this one. No, that's a camping zone. Yeah, El Pina Cate. I guess that's it. Yeah, there's a couple of them right there, but um, interesting that these volcanoes are in the area as well. San Pedro and all this. Um, right here is where the other volcano is, but inside of California, as we are coming up from the Delta, which goes all the way to Salton Butte. Um, that's what I would say. All of this is the California Delta. It's just the water has subsided, and being because of it's being dammed off in the north, of course. And over the years, the water has just kind of dissipated. Do you remember the stories from our first rabbit hole from what 1887 regarding Fort Yuma? Do you remember that story?
Yeah.
Yeah, where Fort Yuma is just inside of Arizona here. Wait, right up in here. No, that's flagged. Sorry, apologize. Fort Yuma. I can't even see it. Right down here. There's Yuma. Fort Yuma back in the 1800s. The Colorado River used to go all the way up into what's now is Laughlin, and they can take riverboats all the way up, and that's how they did. They traversed it. It used to be quite large. It's large now, but not near as large it was. But in the 1800s, the late 1800s, there was a story where we don't know if it's in Mexico, if it's Cerro Preto, Elegante, or up in Salton Butts, but it was right after a series of floods that came through, and the volcano system exploded, and they can see it from Yuma. And it must have rose up, 30,000 feet or more to see it, 200 miles away or 150 miles away, or maybe even 80 miles away. But it had to rise pretty high. And I always think of that because that's kind of close to our time frame, 1980 and then 2006 when the smaller eruption out of St. Helens happened. And that was the last time it did anything. But the 1980 was the big one. On the continental U.S., there are, eruptions up in the Alaskan chain of volcanoes up there on the islands, but the Aleutians. but nowhere else in the continent that's really been active. And 1980 kind of shocked us. Um, we live in a earthquake prone, volcanic prone world, and the world has gone through several um, events where nearly life was wiped out because of volcanoes, whether it be under the surface of the central mid Atlantic or whether it was in Siberia when Pangea existed. Um, life itself was, you know, broken down because you get a bunch of this crap shine up in the atmosphere. All of a sudden, the earth cools. And when it cools, what happens? We freeze and, we don't live here no more. Um, but life is has a way of beating back death to some degree, but it don't take much for life to stop, and that's kind of why we're bringing these volcanoes up. We did earthquakes or fault systems through California and Mexico. We're going to continue as we do these rabbit holes, geographic areas, and then kind of just to bring it to your attention, just you know how things work in the greater system. Our environment is really, really, really crazy, and we take it for granted so much that it doesn't take much for a volcano to just go boom, and then all hell to break loose for the Earth. You know, maybe something will happen over there in China, and it'll shut down all the CCP, but we just don't know. If it does it there, it's going to get all the way to here. But and something to stop this World War III stuff that's going on. But go ahead and talk about Salton Sea volcano there, Canuck.
Yep. So I'm just going to read.
It's in California.
Yeah, the wiki on it because it's
Southern
pretty.
Cal. Okay.
Yeah, pretty detailed. I'll put
All
the
right.
link in there because it's from the list of them that are in the wiki
All right. Cool.
for all the California ones.
Hi, Eden. Hi, Timmy. Hi, girl. Hi, Kat. And who else is out there? Snowplow King and Timmy and Susan. Love y'all. Thanks for being here. All right. So, dun, 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 dun. I had to find it.
See if I can get it in there faster than you.
Okay.
There, I got it.
I got the one. I got the wiki where all of them are on there.
Yeah. Oh, I
Is that
just clicked on Salt and Buttes in there to go to it.
Okay, Salt and Butts. There we go. All right. You want to read it or should I?
I can read it since you've been
Okay.
talking
right.
more. The Salton Buttes are a group of volcanoes in Southern California on the Salton Sea. They consist of a 7-kilometer, 4.3-mile long row of 5 lava domes named Mallet Island, North Red Hill, Obsidian Butte, Rock Hill, and South Red Hill. They are closely associated with the fumarolic field and a geothermal field, and there is evidence of buried volcanoes underground in pre-modern times. Obsidian Butte was an important regional source of obsidian. The Salton
That's crazy.
Buttes lie within the Salton Trough, a tectonic depression formed by the San Andreas and the San Jacinto faults. The depression forms the northward extension of the Gulf of California and is separated from it by the Colorado River Delta. A number of geothermal and volcanic features are located in the area, which is a region of active seafloor spreading. While the Salton Buttes were formerly considered to be of the late Pleistocene epoch, which ended with the end of the last glacial maximum, newer dating efforts have determined that all of them formed more recently during the current Holocene epoch, mostly through effusive eruptions. Future eruptions are possible and could endanger the surroundings. The Salton Buttes lie on the southeastern shores of the Salton Sea, with their peaks at an elevation of 40 meters, 130 feet, in Imperial County, California. The towns of Niland and Calipatria lie northeast and southeast of the Salton Buttes, respectively, and Palm Springs is 140 kilometers, 90 miles northwest. The Alamo River enters the Salton Sea between the Salton Buttes. The name Niland Field has also been applied to the system. Salton Buttes are 5 lava domes that rise 30 to 40 meters, 98 to 131 feet above the surrounding terrain. Each peak is no wider than 1 kilometer, but together they form a chain 7 kilometers, 4.3 miles long. From north to south, they are named Mallet Island, North Red Hill, South Red Hill, Rock Hill, and Obsidian Butte. Of the buttes, the Red Hills and Obsidian Butte are the largest. The Red Hills are a paired volcano connected through pyroclastic deposits. The Red Hills are also known collectively as Red Island. Red Island and Mallet Island were both islands in 2005. As of 2018, Mallet Island is a peninsula. The other domes have also been islands at times, and waves have cut erosional terraces along the former shorelines. The Salton Buttes are lava domes. They form from viscous lava rising in a volcanic vent, 250 meters, 820 feet wide. Obsidian Butte is surrounded by a lava flow, and Mallet Island has a characteristic onion skin foliation. On Red Hill, there is a quarry, a marina, and a trailer park. Busy spot. The Obsidian Butte has been extensively quarried to the point that it has lost most of its original appearance. There are hot springs and moffats on Mallet Island. A fumarole field is associated with Salton Buttes. The field is characterized by griffins and salsas.
Griffin is a flying bird horse.
Yeah.
I didn't understand that.
And I don't know what salsas are either. It's not salsas, it's salsas that are salsa. Yeah. These exhale carbon dioxide and steam, as well as ammonia and hydrogen sulfide. Well, that sounds good. Some of these fumarolic events reach heights of 2 meters, 6.6 feet, and resemble the lava erupting vents. Mud pots are also found. Parts of the field have recently emerged from the Salton Sea due to dropping water levels, which have also caused the fumarolic vents to develop and grow noticeably, including an increased number of griffins. I guess griffins are a thing. There's a geothermal field associated with the Salton Buttes. It is one of the largest and warmest on Earth. Interesting. With temperatures of 360 degrees Celsius, 680 Fahrenheit, at 1.5 to 2.5 kilometers depth. Various volcanic rocks have been found in drill cores at the Salton Buttes. Rocks found inside include andesite, basalt, dacite, diabase, gabbro, and rhyolite. Some of these volcanic rocks bear traces of hydrothermal alteration. In some places, the layers of volcanic rocks are as thick as 100 meters, 330 feet. There may be other volcanoes buried in the sediment pile. At least 4 separate aeromagnetic anomalies have been found at the Salton Buttes, and these may be signs of buried volcanoes. Exciting. The field has been prospected for geothermal power generation, and presently 11 geothermal power plants in the Imperial Valley Geothermal Project have capacity to produce 432 megawatts of power. So that's about half of what Cerro Prieto does. That's pretty interesting. Yeah.
Pretty crazy.
Yeah. So since the Pliocene, the Salton Trough and the Gulf of California have formed an active rift zone south of the San Andreas Fault. In a rift zone, C4 spreading is underway, accompanied by volcanic and geothermal activity, active faulting, and rapid sedimentation. Since 5 million years ago, the buildup of sediments in the Colorado River Delta separated the Salton Trough area from the actual Gulf of California, forming a large depression that currently reaches a depth of 40 meters, 130 feet below sea level. This
Crazy.
this depression is a pull-apart basin. It is formed between various branches of the San Andreas Fault and the San Jacinto Fault, which are connected by the Brawley seismic zone. The Salton Trough is still actively subsiding at rates of 3 millimeters a year, increasing by 4 to 8 millimeters a year in the central area of the trough. A number of quaternary volcanic centers have formed in the region, including Cerro Prieto, Consag Rock, Isla San Luis, Isla Tortuga, the Salton Buttes, and Sierra Pinacate, which is
Sierra Pinacate is the other one I was talking about. Yeah.
yeah, which is the largest of these volcanoes. Strong geothermal activity has been observed as well, with the Salton Trough alone hosting 5 geothermal fields: Brawley Mesquite,
Mesquite.
East Mesa, Heber,
Heber,
and
yeah.
and Salton Sea. These 5 fields have a total heat output of 1,000 to 10,000 megawatts. Wow. Part of this heat output is used to generate geothermal power with annual production of 1.3
Terawatts.
110 to 340 megawatts. Wow.
Pretty crazy.
Yeah. The Salton Buttes volcanoes were formed on quaternary sediments of the Colorado River Delta. Below them, the basement is rock formed from sediments deposited in lakes and by rivers such as mudstones, sandstones, and siltstones. Below this 5-kilometer thick upper layer, there are metamorphic green schist rocks formed by hydrothermal alteration and thermal metamorphism of sediments. And finally, below that, gabbroic rocks at 18 to 10
6.2
kilometers
miles.
depth.
Yeah.
Wow. Diabase and intruded rhyolites have also been identified in the sediments. All of the Salton Buttes, except for Mellot Island, have developed on a liniment. Oh, exciting. A
Interesting.
linear feature with a conspicuous magnetic anomaly.
Magnetic
Volcanoes
anomaly.
seem to share a common feeder dike. This dike may be connected to deep-seated extensional processes along a transform fault that links the San Andreas Fault to the Gulf of California. The sources of heat for the volcanoes and geothermal field is unclear. Both deep mafic and shallow felsic sources have been proposed. Seismic tomography of the area below the Salton Buttes has identified areas in the mantle with an anomalously low seismic velocities, which would be consistent with the higher temperatures there. This thing's pretty good. The domes are formed by rhyolite, which is alkaline and calcium poor composition and defines a potassium-rich suite, whatever a QADF diagram is. Yeah.
It's a suite of things, a group of things.
Yeah. Scarce phenocrysts include
amphibole, anthroclass, apatite, clinopyroxene, luminite, magnetite, arthroproxenine, quartz, and zircon.
Yeah, the tongue twister.
Yeah, boy.
The isotopic composition of these volcanic rocks differs from that of the Salton Sea sediments. The total volume of the domes is 0.5 cubic kilometers.
Interesting how he said the isotopic composition of these volcanic rocks differ from that of the Salton Trough sediments. The total volume of the dome is about a half a cubic kilometer, or about a twelfth, or a twelfth of a cubic mile. that's interesting how the actual composition of the volcanic rocks differs. I guess that's because it's coming up from deep beneath the earth, or deep within the earth and coming up to the surface.
Yeah, they're blowing up through.
Mm-hmm. Through magma, so it changes and it tells you what's way down there below, right?
I don't know if I should read all the rest of this or not because
Well, we're almost done. Obsidian from Obsidian Butte has been identified in a distant archaeological sites. It has been found in the sites in the Colorado Desert, across San Diego County, across from northern Mexico and the southwestern United States. Before Obsidian Butte was emplaced with thus became available for emplaced and thus became available for obsidian production. People in the region used obsidian from the Coso volcanic field, which we're going to talk about later. The trend away, this trend away from Coso towards Obsidian Butte was recognized even before the exact timing of the Obsidian Butte eruption was known. How the magmas are formed is controversial. Explanation has called on several different processes, including assimilation of hydrothermy altered rocks, fractional crystallization, and partial melting. One model presumes the existence of continuously active deep magmatic reservoirs, which generates precursor magmas and episodically delivers them to the shallower magmatic reservoir where the rhyolitics are formed. Xenoliths found in the volcanic rocks include granite, granophyry, metasediments, and theolites, often heavily altered by interactions with the volcanic system. Some of these basaltics resemble those from active rift zones in the Gulf of California and the East Pacific Rise. The northernmost segment of the East Pacific Rise appears to be identical to that of Brawley seismic zone. Yeah, and we don't have to go into the last time it erupted between 1800 and 2300 years ago, although Mullet Island may be 5,000 years older. According to the Global Volcanic Program, Mullet Island formed 290 BCE, plus or minus 100 years. Obsidian Butte, 10 CE, plus or minus 100. 210 from other butts, CE, and plus or minus 100 years. If Mullet Island formed at the same time as the other butts or buttes, the eruption episode from that formed the Salton Butte lasted probably no more than 500 years. Presently, fumarolic activity occurs at the buttes from cracks in the volcanic rocks of the Salton Butte, and seismic activity has been recorded from the geothermal field. So they're thinking 55 to 16,000 years ago. These things, and as many as Salton Butts have dated back some surface volcanic rocks, which rocks, they're way down below being brought to the surface. They're 500,000 years old, 3.8 to a half a million, or 3.8 million years, give or take a half a million years, 960,000 to 190,000 years ago. Now, some of these numbers, if you remember, the last time that Bishop blew up, what is it, 960,000 years ago? So, you'll see some overlap in some of the dates. And interesting that when we watched that earlier documentary, which most of you missed who are online on the other channels, but I showed it here on the Twitch. But you'll hear dates overlap with other events that we've been talking about, other events that Nick Zentner was talking about. And also some of the names that he was talking about kind of bing, 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 came up. It's like, whoa, yeah, that happened. What? And that's where that's happening? And that happened when? Oh, wow. So the more information that we bring to you, the more documentation that we show you, you'll start to see a larger picture about how the West was won, how it was created, and uh, and how important it is to look into some of these um, interesting things to see. And I got a bunch of these um, uh, terminology that I'm not going to bring up to y'all, but you can see I've been doing it as we've been talking here. Um, Sequence of eruptive, the the forms here, the butts of um, by effusive eruptions. The least Obsidian Butte in south of Red Hill also experienced explosive eruptions. These explosive eruptions deposited pumice and tephra. These are all great words, but probably getting a little bit too deep into some of this. Um, but it's interesting how they were created because I thought we were going to try and get through all of them, but I don't know. It is Saturday.
Because it's one of the 4 in California that are ranked as high threat potential.
Yeah, it is a high threat. Yes. So, I mean, the domes were formed by effusive eruptions, but at least Obsidian Butte and South Red Hill also experienced explosive eruptions, which Obsidian Butte preceded the effusive eruption stage. These explosive eruptions deposited pumice and tephra, which were encountered in the drill cores in the area and have also been quarried. Tuffs found farther south at Sierra Prado have been linked to Salton Buttes, but the large distance makes such a link questionable. The idea is that there's a whole large system, and these 2 volcanoes that we've been talking about tonight, the 5 little groups up here in Salton Buttes area and Sierra Prado, they might be linked, but there's really no concrete evidence that that's what they are. It's really interesting though. Of course, there's a bunch of hazards. Yeah. Let's see, in Salton Buttes are considered high hazard zones. Future eruptions may generate pyroclastic flows, pyroclastic surges, which could endanger people within 10 kilometers of the vents. The field is monitored by seismometers and periodic sampling of gas inhalations and hot springs there in a volcano hazard map, but it also incomplete. So they all have to figure that out. Yeah, but interesting for all that stuff. I think we'll go on to the next volcano system going north, and I want to say that's is it? No, it's not Coso. I don't see it on this list. Huh.
Yeah, it's on the moderate threat potential. So they have 5 for that. So causal volcanic field.
Yeah, Salton Buttes is considered a lava dome, and composition is rhyolite. The most recent eruption was about 1,800 years ago, and that's that. The Ubehebe craters, that's the one I'm looking for. There it is.
And Death Valley.
Yeah. Just a little bit north. Let me see. Do I have? Where the heck is it?
Yeah, they have that one there too.
Yeah, let me find. Share this tab. There you go. So in California, right here's the Salton volcano, right? There's another one that we're not going to talk about. There's Malapai Hill, right? And here's Amboy Crater. Here's Pisgah Crater. But Sema Volcanic Field. I think Ubehebe's up here. There it is. Ubehebe Crater is right here, and it's interesting that this area is this volcanic area is current because just not too long ago, over here at Stovepipe, we've had several earthquakes, and I want to tell you how many. Oh crap! Where'd they go? Oh, in the recent days. So, just north of Furnace Creek, probably I want to say quite a bit actually.
Well, what's interesting, because I already read ahead in the wiki,
44 quakes. Yeah.
Ubehebe craters formed 2,100 years ago, so we're looking at same time period as Salton Buttes. So that's interesting.
Wow, man, that's crazy.
Because it was at 1,800 to 2,300 for Salton Buttes, and this one they say was one big episode in 2,100 years ago. So
really?
That's pretty interesting. So this
crazy that some of these things are overlapping, eh?
Yeah.
Yeah. See, here's the list of 44 quakes that happened the last month in a swarm that took maybe a week, 2 weeks. And you can see the 2 yellow marks are within the last few days. So this is just south of what our story is here. So I wanted to bring that to your attention.
Yeah, I'm reading down through the wiki, but it's pretty crazy.
All right. So Ubehebe right up in here. So where is Ubehebe by? Okay. Well, we've talked about Long Valley. We talked about Panamint. We talked about Death Valley, and it's in Death Valley, just on the northern section. The nuke test sites are 100 miles away from it. I want to say, maybe less. Dang it, feet. How much miles? There we go. 76 miles away. And Long Valley Caldera, which is our next stop, is roughly 80 miles to the north.
Yeah. But we got to do Coso too. And
the Coso Range is to the south here.
And Mono and Inyo craters too.
Yeah.
So I want to see if they're all about the same.
Yeah, I want to see too.
It's interesting.
Yeah, we get excited when things start to work, you know. Yeah. Like I'm looking at right now, I don't have this is Coso volcanic field right here. So I need to put it on my list. Volcanoes. What happened? You fall down?
No, I'm just copying this one.
I am too.
Because if you read every one, it's going to take us 2 years to go through.
That's all right. Coso Range. Coso volcanic field.
And the Ubehebe said was Freatomagmatic.
Freatomagmatic. So what do we know about Freatomagmatic? Okay, so we're back over at Ubehebe. Furnace Creek.
Here and there and everywhere.
Yeah, here we go. We're in Ubehebe right here. You can see the crater right there. So go ahead and read your...
Got to bring it back up again.
Alrighty.
Yeah. How many does it say? The Ubehebe craters are a volcanic field in northern Death Valley of California, consisting of 14 to 16 craters in a 3 square kilometer, 1.2 square mile area. The largest of the craters is 800 meters, 2,600 feet wide, and 235 meters, 771 feet deep, Ubehebe crater. Many of the craters, though, are partially buried and thus hardly recognizable. Other volcanic features there include a remnant of a scoria cone and a tuff cone. The Ubehebe craters are associated with a fault system that runs across them. The region has been affected by volcanism for the last 10 million years. The volcanic field is in the Death Valley National Park and is accessible to tourists. The fault system is within the tectonically active Basin and Range Province physiographic region. Various estimates have been put forward for the age of the craters. Recent research has shown that the Ubehebe craters all formed in a single phreomagmatic eruption episode about 2,100 years ago, making it one of the most recent volcanic events in Southern California. The risk of renewed volcanic activity is low. Oh, well, that's interesting. So it's the name comes from the Paiute.
Paiute. Was the peyote came out from the Paiute?
Yeah. I'm trying to. Okay, the Ubehebe craters lie in the northern Death Valley on the slopes of Tin Mountain in the Panamint Range Cottonwood Mountains, about 100 kilometers, 62 miles from Furnace Creek, and 230 kilometers, 140 miles from Vegas. The area is characterized by hills known as the Ubehebe Hills. It's a tongue twister. About 2 kilometers, 1.2 miles from the main crater, a wash flows northward. The volcano lies at an elevation of 752 meters, 2,467 feet, and consists of two mares, Ubehebe Crater and Little Hebe Crater, south of Ubehebe Crater. That's quite the sentence. As well as 14 to 16 craters in an area of 3 square kilometers, 1.2 square miles, with an average diameter of 100 to 200 meters, 330 to 660 feet. The craters are in 4 clusters. Many of the craters are highly eroded and covered with the products of later eruptions. Some are farther buried in alluvium and thus not easily recognizable. Ubehebe Crater is a mare with a width of 800 meters. I already said that. It's the largest one. It has
Ubehebe Crater is the largest one, yeah.
Yeah, it has excavated deep into the underlying basement.
Oh,
sounds like the other.
So that means the erosion has exposed the basement rock.
Yeah.
Wow, that's crazy.
The inner slopes have notably different appearances across a fault that crosses the crater and display both slump deposits, gullies resulting from erosion, and large debris lobes, the largest of which is 200 meters, 660 feet long, and 100 meters, 330 feet wide. At the floor of the crater lies a playa lake, which sometimes flooded. The rim of the crater is covered with black volcanic ash, and it is surrounded by volcanic deposit that reaches a thickness of 50 meters, 160 feet, before thinning with distance. Scorpion weeds and sundrops are occasionally observed growing on the margin of Ubehebe Crater. Little Hebe Crater is a tuff cone whose crater is 100 meters, 330 feet wide, and 20 meters, 66 feet deep. It is surrounded by pyroclastic surge deposits that show striking white and black bands. Little Hebe seems to have formed with an elongated depression known as an amphitheater. The remnants of a scoria cone are between this depression and Ubehebe Crater. The other craters form a group west of Ubehebe Crater, and another isolated crater is southwest of the group. Only Ubehebe Crater appears to reach the non-volcanic basement. The other craters are embedded in ejecta. Pyroclastic deposits reach distance of up to 4 kilometers, 2.5 miles from Ubehebe Crater, and cover an area about 15 square kilometers with a layer less than 50 meters, 160 feet thick. They are classified as base surges, which are turbulent flows formed when magma and water interact with water in an explosive manner. The deposits are graded and show wave-like structures that form conspicuous ripples and wave fields where exposed by steam erosion or road cuts. Blocks with sizes up to 15 centimeters, 5.9 inches, are embedded in the deposits, which are covered by volcanic ash, lapilli, and lava bombs. Wow.
Mm-hmm. Well, it's a little lapilli is a little rocks that are aromatic. I mean, it's got little tiny holes in it, and because of the gases are still, as they get shot in the air, they're still expanding, and so the oxygen is able to, and the gases are able to remove, leave the rock itself. So it's a little tiny, like pumice, but lapilli is a really small, very, very small stuff.
Oh, so I'm jumping down into the geology part. The Ubehebe crater are atop a fault that forms the edge of the Tin Mountain Range. Adjacent to the craters, the fault has formed scarps. The fault is known as the Tin Mountain Fault, which cuts through Ubehebe crater. That's interesting. The branches then branches out in a diffuse set of faults. This fault intersects the nearby northern Death Valley Fault close to the Ubehebe craters. The latter fault may have ruptured at the same time or soon after an eruption in the volcanic fields. Wow. Well, that's interesting. So you got all these blowing up around the same time on
Right.
multiple fault lines.
So this is the picture of Ubehebe crater.
And it's close to Death Valley Fault.
Yeah.
And we have Cerro Prieto on the Cerro Prieto Fault. And we have Salton Buttes on Imperial, basically, Brawley seismic zone. Well, this is getting more interesting now.
You can see pretty deep these things are, 720 foot deep. Boom, exploded, man. Can you imagine, how much rockets shot out into the atmosphere? Crazy.
Yeah, I'm jumping down because I don't want to. There's no evidence of geothermal activity there in Ubehebe craters. However, sulfur degassing was recorded after the 2019 Ridgecrest earthquakes.
Oh,
that's interesting.
So what did they say again? Read that again.
Yeah, it said there is no evidence of geothermal activity, and here does not appear to be a magma reservoir underneath the volcano. However, sulfur degassing was recorded after the 2019 Ridgecrest earthquakes. Yeah, I've heard this one before. It's related, even though it is.
Well, we also heard during or right after, or real close to the time of that, Palm Springs had sulfur coming up out of the ground before Ridgecrest as well.
Yeah.
And after, by the way. So a lot of that was happening. That's crazy.
Yeah. Oh, and down at the hazards part now. The discovery of recent Holocene activity, which was initially assumed to have been protracted over time, has led to the California Volcano Observatory commencing volcano monitoring at the Ubehebe craters, including the installation of one seismometer. The volcano is classified as moderate threat volcano in the USGS Volcanic Threat Assessment. An incomplete circular 10-kilometer wide 6.2 mile volcano hazard zone has been defined for the Ubehebe craters, which reaches Scotty's Castle, within which pyroclastic surges and steam blasts could be expected in case of renewed eruptions. Future eruptions of the Ubehebe craters may impact the almost a million annual Death Valley National Park visitors and about 100 people who live in the region. However, the apparently monogenetic nature of the Ubehebe craters implies that the risk for renewed eruptions is low.
Right. Scotty's Castle is known as the Death Valley Ranch. It's a Spanish colonial style villa out there in the middle of freaking nowhere. It's 45 miles north of Stovepipe Wells, which is what we're talking about a little bit earlier, on California State Route 190 on to Scotty Castle Road, about a 3-hour drive from Las Vegas. Interesting. If you go into that area you want to visit, Scotty's Castle was severely damaged by flooding in October 2015 and a fire in 2021 that destroyed the historic garage workshop that was used as a visitor center. This caused Scotty's Castle to be temporarily closed to the public. On December 23, the official social media accounts of Death Valley National Park announced that they were opening Scotty's Castle again for winter of 23-24. So it's open for visitors. Despite many of the park's main roads still being closed from damage by Hillary hurricane. So it's interesting that that's pretty close to Ubehebe crater. And I mean, this little castle is like out in the freaking middle of nowhere, man. Spanish style castle. It's the area of the ranch is 719 hectares. Wow. Well, anyway, it's there on the in the valley. Crazy stuff, man.
Yep. So what are we doing next?
Coso volcanic field. All right, let me change the map here for you. Zooming out. Yeah, Scotty's is down in here. There's Ubehebe. They said only not too far. Here's the ranger station. I think over here on 190. Scotty's Castle Road. There's the ranger station. I don't know where the Lower Vine Ranch. Ubehebe craters. Pretty amazing, though. You can see just the topography, how dark it is. It's not really dark. We have areas in California that are much more darker than these. And to show the recent activity, which I think is pretty cool to even compare with some of the stuff. Now we're going to talk about the Coso Volcanic Field, which is here's Ubehebe up there in the north, just south. Let me see how many miles from there. As a bird flies, 70 miles south. All right. Is pretty close to a Big Pine Volcanic Field, too. Over the mountains, 50 miles. And up to Long Valley, about 80 miles. So Ubehebe crater is pretty interesting stuff. And it's not too difficult for you to get to, and it's relatively safe, speaking. And you know how I feel about people going to volcanoes and checking them out. But we're going to talk about this Coso Range right now. Alrighty. Dun, 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 dun. All right. The Coso Volcanic Field is located in the Inyo County, California, at the western edge of the Bay Center Range geologic province in the northern edge of the Mojave Desert. The fossil falls are part of the Coso Field, created by prehistoric Owens River. They are within the Naval Air Weapons Station, China Lake, and northeast of Little Lake on Route 395. The initial volcanism at Coso preceded the onset of the Bay Center Range. So we're talking quite a ways back. Crustal extension there has expressed by normal faulting. The earlier of the two principal periods of volcanism began with the emplacement of basalt flows over the surface of little relief. Then during the ensuing period, approximately 1.5 million years ago, there's that time period again. Um, a hiatus, following a 1.5 million year hiatus with few eruptions, a bimodal volcanic field of basalt lava flows and rhyolitic lava domes and flows developed on the basin range terrain of essentially the same form of today's landscape. Many of the young basalt flows are the intercanyon occupying parts of the present day drainage system. The coastal volcanic field is best known for its Pleistocene rhyolite, 38 rhyolite domes and flows from the elongate array atop a northern trending 8 by 20 kilometers or 5 by 12 miles horse of Mesozoic bedrock. Nearby uneroded constructional forms are exhibited by most domes. Many area Many are nested with tough ring craters, and few filled and erode their craters to feed flows a kilometer or two long. The two oldest domes contain several percent phenocrysts or phenocrysts. I don't have that word up there. Uh, the rest are essentially aphric. Obsidian is exposed locally on most extrusions, and analysis of fresh glass indicate that all of the rhyolite it is of the so-called high silica variety. The SiO2 content is essentially consistent or constant at 77%. Other major elements constituents are nearly invariant. However, trace element contents vary and help define 7 age groups, each with a unique chemical composition. Um, the obsidian from the Coso Range field was heavily exploited by Native American Coso people to make knives and projectile points and like hues and the like. Um, the chief period of exploitation was between 3,000 and 1,000 years ago, when people mined obsidian by constructing benches in hillsides and digging deep pits to access raw materials. Obsidian from the volcanic fields was traded all the way to California coast in San Diego, San Luis Obispo, in Central Cali, in Santa Barbara, California, and throughout the Mojave Desert, and regions further east. Archaeologists recognize at least 4 different geochemical sources: Sugarloaf, West Sugarloaf, Joshua Ridge, and West Cactus Peak. These different subsources were used to of varying degrees in different time periods, but the Sugarloaf and the West Sugarloaf was the most commonly exploited geochemical types. Now, there's also a geothermal power plant here as well, and we talked about that. This one does, in the 1970s, it had potential resources of 650 megawatts of electricity, and with a lifespan of about 30 years. Judged by the youthfulness of the rhyolites lavas and by the zone of low seismic velocity crust roughly beneath the rhyolite, a magma body may be the source of thermal energy for a geomagnetic system. Commercial power development began in the 1980s, located in the Naval Air Weapons Station, Ridgecrest, station near Ridgecrest. Power plants at the Coso Geothermal were operated by a company out of Nevada and sold in 2006. Currently produce 270 megawatts from 4 geothermal plants. More than 100 wells have been drilled throughout the field. The production depths are from 2,000 to 12,000 feet deep. Hold on. Yeah, there, 2,000 to 12,000 feet deep. And the temperatures range from 200 to 350 degrees Celsius, 392 to 662 Fahrenheit. Coso began generating electricity in 1987. Improvements have resulted in more efficient uses of the resource. Seismicity. The Coso volcanic field is one of the most seismic active regions in the United States, producing dozens of tremors in the magnitude 1, 2 range each week. Tremors of magnitude 3 occur at a rate of 2 to 6 per month. Magnitude 4 quakes occur 2 to 3 times each year, and recent activity in the magnitude 5 range happened in 1996 and 98 when tremors of 5.3 and 5.1, 5.2, and 5.0 occurred within a day of each other. The tremors were actually recorded along the eastern side of the coastal volcanic field, 15 miles. September 30th of 2009 and October 6th of 2009, there have been 429 earthquakes ranging from 0.1 to 5.2. Some days have had activity at one tremor every minute. On October 2nd in 2009, there were 3 earthquakes, 5.2, 4.7, and 4.9, all within an hour of each other. So it does have its moments when it just decides to kick off.
Yeah. And Ridgecrest had a swarm in 95 before Colima had the 8.1.
Mm-hmm.
And then it's talking about that there was other magnitude 5 ones in both 96 and 98. So that would have been after Colima 8.1.
Yeah, and and again the extension of
it acted up in 2009 near the end of the year, so that would have been right before the Baja quake.
October 2nd, 2009. Yep, interesting there, eh? July 4th and 5th of 2019, 2 large earthquakes sparked a surge of activity in the area. The first large quake measured 6.4. The second was a M.1 or 7.1, sorry, and then Ridgecrest there. Within a week, more than 8,000 magnitude 1 to 4.5s or smaller earthquakes had joined the swarm through only 27 quakes larger than 4.5 occurred. Surprisingly, there are no fatalities in California. One guy did die, heart attack, he was working under the truck and it fell on him. 2 structured fires lost and some of the other Trona and all that. Highway 178, one of the 2 ways out of Trona, was blocked from rock slides and passable shifting of sections of the asphalt. And, all that stuff. So earthquake swarms are common in the coastal area, often producing hundreds of tremors over periods of short few days. The brisk and robust seismic activity is common in volcanic areas such as Long Valley, Mammoth, Yellowstone, and Yellowstone caldera at Yellowstone. The coastal volcanic field shows examples of volcanic activity probably last active 30 to 40,000 years ago. But ash emissions and small cones building episodes may have been in less than 10,000 years in age. So there's coastal hot springs, coastal range, coastal rock and art district, and fossil falls, and the like. So I think we'll continue moving north. And I don't know. I think which one would it be?
Mono Inyo, probably.
Mono Inyo craters. That's well. Why wouldn't a super volcano be first? There's Mono Lake or Mono Inyo
below Long Valley. I can't remember.
Yeah, Mono's above it. So Long Valley's next, but they don't have anything on Mammoth Mountain we can do as well. All right, we'll do Mammoth Mountain first.
Yeah, Mammoth Mountain is basically on the edge of the Long Valley.
Yeah. I guess. We're gonna go on up this road right here, 395, which is they're all close together. Here's Big Pine Volcanic Field. We're not touching that yet. That'd be I don't think that would call that Inyo craters. But there is a volcanic field. Interesting that it's not on our list because I guess it's dead. So they think. Long Valley Caldera is the next. And then Mammoth, and then Inyo craters, and then Mono Lake.
Yeah.
So most everybody knows about Bishop or Long Valley Caldera, but we'll talk a little bit about Mammoth first, eh?
Yeah.
So go ahead and you can read that one.
I got to go back here. Got too many pages open.
I know. I'm looking at probably 25.
Yeah.
Yeah.
Okay, the Mammoth Mountain Wiki.
Yeah.
It's not too It's not too bad.
It's okay. We'll take as long as we need.
Mammoth Mountain is a lava dome complex partially located within the town of Mammoth Lakes, California, in the Inyo National Forest of Madera and Mono counties. It is home to a large ski area, primarily on the Mono County side. Mammoth Mountain was formed in a series of eruptions that ended 57,000 years ago. Mammoth still produces hazardous volcanic gases that kill trees.
So it's
Ma-
very active, everybody.
yeah, Mammoth Mountain is a lava dome complex in Mono County, California. It lies in the southwest corner of the Long Valley caldera and consists of about 12 rhyodacite and dacite overlapping domes. These domes formed in a long series of eruptions from 110,000 to 57,000 years ago, building a volcano that reaches 11,059 feet in elevation. During this time, massive dacite eruptions occurred roughly every 5,000 years. The volcano is still active with minor eruptions, the largest of which was a minor phreatic eruption 700 years ago. Mammoth Mountain also lies on the south end of the Mono Inyo chain of volcanic craters. The magma source for Mammoth Mountain is distinct from those of both the Long Valley and the Inyo craters. Mammoth Mountain is composed primarily of dacite and rhyolite, part of which has been altered by hydrothermal activity from fumaroles. Mammoth is outgassing large amounts of carbon dioxide out of its south flank near Horseshoe Lake, causing mazaku in that area. Must be killing the trees, I guess. That must be what mazaku is. Must be Japanese word for it. The concentration of carbon dioxide in the ground ranges from 20 to 90% CO2. Measurements of the total discharge of carbon dioxide gas at the Horseshoe Lake tree kill area range from 50 to 150 short tons per day. This high concentration causes trees to die in 6 regions that total about 170 acres in size. The tree kills originally were attributed to a severe drought that affected California in the late 1980s and early 1990s. Another idea was that the kills were the result of a pathogen or other biological infestation.
Like a beetle.
However,
Yeah.
yeah, however, neither idea explained why all trees in the affected areas were killed regardless of age or health. Then in March 1990, a U.S. Forest Service ranger became ill with suffocation symptoms after being in a snow covered cabin near Horseshoe Lake. Oh. Measurements around the lake found that restrooms and tents had a greater than 1% CO2 concentration, toxic, and a deadly 25% concentration of CO2 in a small cabin. Wow. CO2 concentrations of less than 1% are typical and healthy in most soils. However, soil concentrations of CO2 in the tree kill areas range from 20 to 90%. This overabundance of CO2 was found to be the cause of the tree kills because tree roots need to absorb oxygen directly, and the high CO2 level reduced available oxygen. Researchers also determined that mammoth releases about 1,300 short tons every day. As of 2003, the concentration of carbon dioxide in soil gas at Mammoth Mountain is being monitored on a continuous year-round basis at 4 sites, 3 at Horseshoe Lake and 1 near the base of Chair 19 at the ski area. The most likely sources of CO2 are degassing of intruded magma and gas release from limestone-rich metasedimentary rocks that are heated by magmatic intrusions. The remarkable uniformity in chemical and isotopic composition of the CO2 and accompanying gases at different locations around Mammoth Mountain indicates that there may actually be a large reservoir of gas deep below the mountain from which gas escapes along faults to the surface. Measurements of helium emissions support the theory that the gases emitted in the tree kill area have the same source as those discharged from Mammoth Mountain fumarole. There's evidence that the rate of CO2 discharge has been declining, with emissions peaking in 1991. That's interesting.
Well,
So it started going up in the 80s after all those
right.
quakes we talked about before, and then
The two of them 5 mass extinction events that happened on our planet that took out 96% of all life and 80% the next time happened because of those two gases.
so I
So
wonder
it's
how long it'll be before the skiers at Mammoth Mountain have to pay a carbon tax.
a lava dome. Let me explain here what a lava dome is too. It's different from a stratovolcano. Stratovolcano is that teepee looking thing, right? A lava dome is a circular mound-shaped protrusion resulting from slow extrusion of viscous lava from a volcano. It means it doesn't move very fast. It moves very slow. Dome building eruptions are common, particularly in convergent plate boundary settings. Around 6% of eruptions on Earth are lava domes. Only 6%. It's crazy. The geochemistry of lava domes can vary from basaltic to rhyolitic, although the majority of intermediate composition, such as volcanoes like Santa Guido, a diacite, andesite present day. The characteristic dome shape is attributed to a high viscosity that prevents the lava from flowing very far. The high viscosity can be obtained in two ways: high levels of silica in the magma or by degassing of fluid magma. So up here, it's either high silica or by a bunch of degassing of fluid magma. So what do you think is happening right there? We just talked about the trees dying, right? It's probably fluid magma somewhere close to the surface, or there's a crack all the way down, right? Since viscous basalt and andesitic domes weather fast and easily break apart by further input of fluid lava, most of the preserved domes have high silica content and consist of rhyolite or diacite or dacite, sorry. Existence of lava domes have been suggested for some dome structures of the moon, Venus, and Mars. The Martian surface in western part of Acadia Planetalia, or, well, that sounded nasty, Planetea, and within the terrace. Lava domes evolve unpredictably due to their nonlinear dynamics caused by crystallization and outgassing of the high viscous lava in the dome conduit. Domes undergo various processes such as growth, collapse, solidification, and erosion. So that's kind of what I wanted to bring to that, because it's different from a stratovolcano where the explosions keep happening and that's what's building the tower that goes up, right? So back to your list here. We talked about the volcanic discharge. We don't need to talk about anything else. I think we'll do Mono Inyo craters, right? We'll do that one next.
Yep. Which
is just north of Mammoth right here, right? There's another volcano called Red Cones. It's not on our list, but we're going to talk about these stuff because these are the active ones, everybody. There's a series of volcanic craters from Mammoth Mountain all the way over to Mono Inyo craters and then Mono Lake, which is active right there, right? Or right here. Pohoa Island, whatever they want to call it thing. But Mono Lake, right? So Mono Inyo craters is what we're going to talk about now. Again, our purpose here is to get you familiar with the different volcanoes that are active. And these are the ones that are on the list, the California watch list, okay? So
yeah, they're all ones they think that are a threat.
Mm-hmm. The threat list. The Mono Inyo craters are a volcanic chain of craters, domes, and lava flows in Mono County, Eastern California. The chain stretches 25 miles from the northwest shore of Mono Lake to the south of Mammoth Mountain. The Mono Lake volcanic field forms the northernmost part of the chain and consists of two volcanic islands in the lake and one cinder cone volcano on the northwest shore. Most of the monocraters, which make up the bulk of the northern part of the Mono Inyo chain, are phreatic steam explosions. That means there's a lot of something going on underneath there, right? That have since been either plugged or topped by rhyolitic domes and lava flows. The Inyo craters form much of the southern part of the chain and consist of phreatic explosion pits, rhyolitic lava flows, and domes. The southernmost part of the chain consists of fumaroles and explosion pits, and on Mammoth Mountain and set of cinder cones, such as the mountain, the latter are called red cones. I just said that, right? Eruptions along the narrow fissure system under the chain began in the west moat of the Long Valley Caldera, 400,000 to 60,000 years ago. Mammoth Mountain was formed during this period. Multiple eruptions from 40,000 to 600 years ago created the monocraters, and the eruptions of 5,000 to 500 years ago formed the Inyo volcanic chain. Lava flows 5,000 years ago built the red cones, and explosion pits on Mammoth Mountain were evacuated in the last 1,000 years. Uplift of Pahola Island in Mono Lake about 250 years ago is the most recent activity. These eruptions most likely originated from small magma bodies rather than from a single large magma chamber, like that of the massive Long Valley Caldera 760,000 years ago. During the past 3,000 years, eruptions have occurred over every 250 to 700 years. In 1980, a series of earthquakes uplift within the southern or the south of Long Valley Caldera indicated renewed activity in the area. 1980 was the time that, and we talk about this all the time when St. Helens popped. Not only did St. Helens pop, but also what? Off the shore of California, Northern Cal, had a big earthquake. And then the 3.6s that happened here. The region has been used by humans for centuries. Obsidian was collected by Mono Paiutes for making sharp tools and aeroplanes. The glassy rock continues to be removed from modern times from use as commercial score and yard decorations. Mono mills process timber felled on near the volcanoes in the nearby boomtown of Bodie in the late 19th to the 20th centuries. Water diversions into the Los Angeles aqueduct system from the natural outlets of Mono Lake started in 1941 after the water tunnel was cut under the Mono craters, Mono Lake volcanic field, and a large part of the Mono craters gained some protection under the Mono Basin National Forest Scenic Area in 84. Resources used along the chain of managed by the United States Forest Service and part of the Inyo National Forest. Various activities are possible along the chain, including hiking, birdwatching, canoeing, skiing, and mountain biking. Monocraters are 10.5 miles chains of at least 27 volcanic domes. 3 large glass flows called coulees and various explosion pits on and other associated volcanic features. The domes of the chain lie on roughly north-south trending arc and concave to the west and located south of Mono Lake. The highest of the Mono crater domes is Crater Mountain, elevation of 9,172 feet, which rises 2,400 feet. So it starts at 9,100 feet and goes up 2,400 feet. above Pumice Valley to the west. Associated volcanic features are located at Mono Lake, Pau, and Neget Islands on its northern shore, Black Point, the Coulees cluster north and south of the overlapping chain of domes. The Inyo volcanic chain stretches 6 miles from Wilson Butte into Inyo craters proper. The Inyo craters are open pits in forested areas, are about 600 feet across and 200 feet deep, each with small ponds covering their floors. A quarter mile north of these is another explosion pit on top of Deer Mountain. Farther north of these craters are 5 lava domes, including Dead Man Creek Dome, Glass Creek Dome, Obsidian Dome, and Wilson Butte or Butte. These domes are composed of gray rhyolite, frothy pumice, and black obsidian. The Inyo volcanic chain extends into Long Valley caldera, but is not related to the caldera volcanism itself. Red cones, which we talked about, south on the Inyo volcanic chain, are other features related to the dike system responsible for creating the volcanoes and lava flows, for creating the craters, volcanoes, and lava flows. These include a north-south trend of fault scarps up to 20 feet high and pulled apart cracks of fissures in the earth. These fissures are not tectonically faults, not technically faults, because little or no vertical or horizontal movement has occurred along them. Most notably, these is earthquake fault, a fissure up to 10 feet wide, cuts 70 feet into glassy rhyolic lava flows. These features are formed by stretching induced by intrusion of the Inyo dike. Stairs to the bottom of the fissure were removed after being damaged by earthquakes in 1980. Several mono Inyo related explosion pits are on Mammoth Mountain. The red cones south of Mammoth Mountain are basaltic cinder cones and are the southernmost part of the mono Inyo craters volcanic chain. Pretty crazy, man. I got a pretty good picture here. Let me share those with share this tab. There you go. See how it's kind of boom, 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 right? And Mammoth Mountain's up in there, or yeah, Mammoth Mountain's up in there. So it's looking from the vantage point of Mono Lake, looking south. I think that's what it's doing. I'm gonna spin myself around. Yeah, the mountains are to the west. So yeah,
it's right on the edge.
Yeah. So interesting. And then Red Butte is like way up on the other side, or Red, whatever it was. Pretty crazy, man. And you can see that there are areas where there's at the end of it is water down here. Don't swim in it, baby. Don't swim. Uh-oh. 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 No, tell me. These butt brains are shooting rockets again? Never learn, do they?
I haven't heard that in like a
couple of days. Yeah. He's putzes, man.
Yeah, I must have found some more to shoot off, I guess.
All right. So we can probably talk about a Mono Lake volcanic field or Long Valley. I think we'll go to Long Valley.
Yeah.
So you can go ahead.
It says there in the geology thing that they think, well, all these ones are new, right? Since Long Valley blew up.
760,000 years ago, yeah.
But in the geology stuff they talk about, they think there was a bunch of volcanoes where Long Valley was before. So what that seems like to me is there was a volcanic field where Long Valley was before it blew up, which goes to my theory that every volcanic field is a potential caldera if it blows.
Well, yeah. What is a caldera? By definition, is when everything blows out and the floor of the volcano just collapses.
Yeah.
That's what a caldera is. I,
Yeah.
I happen to think that the size of Long Valley and and Mono Lake, I think it's the same system. It just happens to be moving, but maybe it's moving along. You know.
Well, it's moving like with how North America is moving.
Mm-hmm.
So if that's the case, the new Long Valley caldera is right under where that big dome is, right in the middle, with the crack down the middle. That's the Kern River Canyon.
Oh, you think it's down here?
Yeah, because if it's moving southwest, that's where it would be moving to, right?
Well, North America on this part of the mountains is moving due south, and out here it's moving to north or north. And this is all compressional. We just learned about that, right? And the Sierra Nevadas are 120 to 150, 180,000, a million years old.
Or they're
So,
all along the Walker Lane lineament. They're all
right.
along that.
Yeah. And they're due
The
to
opposite way, northwest to south.
the compression of or a non-existent um, subduction zone that existed out here that since has been subducted and it disappeared on the Farallon plate because it's gone.
But
And
if
what's
you keep
left of it is the
if,
Juan de Fuca plate.
if you keep going up, those all run right into the Cascades,
Oh yeah, oh yeah,
west and south.
and
Line.
yeah, which is the bottom it is Lassen, which again is a volcanic field, not just a one big stratovolcano, but a volcanic field.
Well, you can follow them all the way from.
Oh, you can follow all the way up. You
You can
know,
follow them all the way from
up,
Antarctica,
up,
right on up on the
yeah,
northwest to southeast line, going right
yeah.
up.
It's Shasta being out here toward the coast, and all of a sudden you got Medicine Lake. I mean, there's a series of volcanoes and um, cones and the like that, interesting enough, aren't considered part of the Cascade Range. And they're more dense, there's what 18 in Portland or something, or in Oregon, and then there's a bunch up, a whole ton of them up in Washington. And there's two series. There's like volcanoes that existed 50 million years ago that are dead and gone, and now all the new cascades are here. So very interesting on how all of these volcanoes and every red dot you see on the list here is a volcano. And it's not all of them, but yeah. I think what time are we on here? We're an hour and 38. So how you doing? You good?
Yeah, still good. I don't know how far we're going to get, but we'll see.
Well,
Because I'm thinking all sorts of other things now that I have all the dates in my head.
yeah, the dates are playing with you, huh?
Yeah. Because
Yeah,
all the stuff at the bottom is relatively like super new.
right.
And the farther we go up, it seems to
It's
be
a little
getting,
older, isn't it?
yeah.
Yeah. The Long Valley Caldera is a depression in the eastern California that is adjacent to Mammoth Mountain. The valley is one of the Earth's largest calderas, measuring 20 miles wide by 11 miles long, or 20 miles long by 11 miles wide, and up to 3,000 feet deep. The valley is formed 760,000 years ago when a very large eruption released hot ash that later cooled and formed the Bishop Tuff that is common to the area. The eruption emptied the magma chamber under the area to the point of collapse. The second phase of the eruption released pyroclastic flows that burned and buried thousands of square miles. Ash from the eruption blanketed much of the western part of what is now the United States. The caldera is a giant bowl-shaped depression, approximately, like I said. The elevation of the bottom of the bowl ranges from 6,500 to 8,500 feet, being higher in the west. So the side of the mountain, right? Near the center of the bowl, magnetic uplift was formed a resurgent dome. It means it's not dead. The southeastern slope of the caldera down towards Bishop, California is filled with Bishop Tuff, a solidified ash that was ejected during the eruption that created the caldera. The Bishop Tuff is 4,900 foot thick in the caldera floor, on the caldera floor, and is cut by the Owens River Gorge, formed during the Pleistocene when the caldera filled with water and overlapped its rim. The rim of the caldera is formed from pre-existing rock, rising about 3,000 feet above the caldera floor. However, the eastern rim is lower, only about 500 feet. So it's lopsided, right? Mammoth Mountain is a lava dome complex west of the structural rim of the caldera, consisting of 12 rhyodacite and dacite overlapping domes. These domes formed in a long series of eruptions from 110,000 years ago to 50,000 years ago, building a volcano that reached 11,059 feet. The Mono Inyo craters are 25 miles long volcanic chains situated along the narrow north-south trending fissure system extending along the western rim of the caldera from Mammoth Mountain to the north shore of Mono Lake. Mono Inyo craters erupted from 40,000 years to 600 years ago. These magmatic sources are separate from the Long Valley caldera. The caldera has an extension hydrothermal system. Casa Diablo Hot Springs, at the base of the resurgent dome, hosts a geothermal plant. Hot Creek cuts part of the resurgent dome and passes through Hot Springs. The warm water of Hot Creek supports many trout and is used at Hot Creek hatchery. The creek was closed during the swimming in 2006 after geothermal activity in the area increased. The area has a number of other hot springs, some of which are open to bathers. The tectonic causes of Long Valley volcanism are still largely unexplained and are therefore a matter of much ongoing research. Long Valley is not above a hotspot, such as those that fuel Yellowstone, or the volcanoes in Hawaii, or the result of subduction, such as that which produced volcanism of the Cascades. The known volcanic history of Long Valley area started a few million years ago when magma began to collect several miles below the surface. Volcano activity became concentrated in the vicinity of the present site of Long Valley caldera 3.1 to 2.5 million years ago, with eruptions of rhyodacite followed by high silico-rhyolite from 2.1 to 800 million years ago, or 0.8 million, about 800,000 years ago, okay? After some time, a cluster of mostly rhyolite volcanoes formed in the area. All told, about 1,500 square miles were covered by lava. All but one of these volcanoes, 1 to 2 million years old, Glass Mountain, made of obsidian, were destroyed by the major volcanic explosive index of VEI 7 eruption of the area 760,000 years ago, which released 600 cubic kilometers, 144 cubic miles of material from vents just inside the magma or the margin of the caldera. The 1980 Mount St. Helens eruption was a VE5 eruption releasing 1.2 cubic kilometers or 0.29 cubic miles. Huge difference. 144 cubic miles to a third of a cubic mile. That's the difference between the two. Huge difference. About half the material was ejected in a series of pyroclastic flows of hot 1500-degree Fahrenheit mixture of noxious gases, pumice, and volcanic ash that covered the surrounding area hundreds of feet deep. One lobe of the material moved south into Owens Valley, past the present-day Big Pine, California. Another lobe moved west over the crest of the Sierra Nevada and into the drainage of the San Joaquin River. The rest of the pyroclastic materials, along with 300 cubic kilometers or 72 cubic miles of material, was blown as far as 25 miles into the air, where winds distributed as far away as Nebraska and Kansas. The eruption initially produced a caldera 1.2 to 1.9 miles deep. However, much of the ejecta went straight up and fell straight down, thus creating the lahars and all that other stuff, and filled the initial caldera about 2/3 full. Can you imagine 144 cubic miles of dirt explodes and 2/3 of it falls right back down? It's like something under there went and it went up and it came right back down on itself. I wonder why. Why
And
didn't
so
it just blow it out everywhere else?
yeah, this would have been before the last Yellowstone eruption.
Yellowstone popped, what, 1.2?
No, 640.
640? Okay.
I think it said 640.
Yeah. So this happened 760 miles. Right.
So this was before Yellowstone last.
Yeah. Subsequent eruptions from the Long Valley magma chamber were confined within the caldera with extrusions of relatively hot, crystal-free rhyolite 700,000 to 600,000 years ago, as the caldera floor was uplifted to form the resurgent dome, followed by extrusions of cooler, crystal-rich moat rhyolite. At 200,000 years intervals, 500,000, 300,000, and 100,000 years ago, in clockwise succession around the dome, the declining volcanic activity and increasingly crystalline lava extruded over the last 650,000 years, as well as other trends suggest that the magma reservoir under the caldera has now largely crystallized and is unlikely to produce a large-scale eruption in the future. So when it crystallizes, it dies, turns into granite. The Long Valley volcano is unusual in that it produced eruptions of both basaltic and silicic lava at the same geologic place. Water from the Owens River filled the caldera to a depth of 300 meters or 984 foot as of 600,000 years ago. At that same time, the lake's surface was at an elevation near 7,500 feet. The lake drained some time in the last 100,000 years after it overtopped the southern rim of the caldera, eroded the sill, and created the Owens River Gorge. A human-made dam in the gorge has created Lake Crowley, a partially restoration of the original lake. Since the Great Eruption, many hot springs developed in the area, and the resurgent dome has uplifted. During the last ice age, glaciers filled the canyons leading into Long Valley, but the valley floor was clear of ice. Excellent examples of terminal moraines can be seen at Long Valley, Laurel Creek, Convict Creek, and McGee Creek. Each have prominent moraines. In 1980, a strong earthquake swarm included 4 Richter scale. Four of them, 4 6s, struck the southern margin of the Long Valley caldera, associated with a 10-inch dome-shaped uplift of the caldera floor. These events marked the onset of the latest period of caldera unrest that is ongoing. This ongoing unrest includes reoccurring earthquakes, swarms, and continued dome-shaped uplift of the central section of the caldera, accompanied by changes in thermal springs and gas emissions. After the quake, a secondary access road was created as a potential escape route for the town of Mammoth Lakes. It's now, at first, it was proposed as the Mammoth Escape Route, but was changed to the Mammoth Scenic Loop after Mammoth area businessmen and landowners complained. Wah, wah, wah. In 1982, the United States Geologic Survey, under the Volcanic Hazards Program, began an intensive effort to monitor and study the geologic unrest under the in the Long Valley caldera. The goal is to provide residents and civil authorities with reliable information and the nature and potential hazards posed by the unrest that's in the valley. Maybe an impending volcanic eruption. Who knows? Most, perhaps all, volcanic eruptions are preceded and accompanied by geophysical and geochemical changes in the volcanic system. Common precursor indices of the volcanic activity include increased seismicity, ground deformation, and variations in the nature and rate of gas emissions. And we've already talked about the hydrothermal systems. It has a huge one. I mean, a huge one. Let me see if I can see. I'm trying to find out how much it produces. It's got a lot. It's a lot of hot. Yeah, there's a lot of hot tubs and stuff too. So, yeah, in April 2006, 3 members of the Mammoth Mountain Ski Area Patrol died because of suffocation of carbon dioxide when they fell into a fumarole on the slopes of the mountain. Not good. Not good at all. It doesn't tell me how much it produces. This hydrothermal plant. So, hey, whatever. I think because we've handled this, I think this is where we should stop, actually. Already down to 52.
Right now.
Yeah. Well, we had the video that went a little bit longer than I anticipated. It went almost 30 minutes.
Yeah.
But yeah, we'll continue this.
We still have to do all the Clear Lake and the northern ones.
Yeah. And I want to spend some time on some of those traces too. I'm going to look up some of those others. We've pretty much covered the southern part of California. So if we divide California in half, we've done a fair amount of volcanic stuff, and we didn't talk about the Sema volcanic field that's out here, or the Lava Lake, Pisgah craters. We didn't talk about that, or Amboy. We didn't talk about any of those, and those are in the south, in the Mojave Desert, actually. Pinnacles we haven't talked about, but then again, they're not considered threats. What we're dealing first is with the threats, and we're trying to keep you abreast of the threats, right? Yeah. So there's also a church butte out in as we go north in Nevada, and then there's Sutter Butte or Butte, and then there's Clear Lake, which is the other one we need to talk about. And you can see Pinnacles is here along the coast, mountains. There's Diablo, which is right in here, right? And then just north of that, there's Bohemian Grove, which is where all the heads of state go and they do their bad stuff, which it's up here, and so that's going to sink into the ocean. St. Helena, there's a volcanic system up in here, and then here's Clear Lake. So we're going to talk about all these, including this whole series of volcanoes on the next rabbit hole. So if you like them, come over and join us over at twitch.tv/Joe Slick Live, or you can remain here on Wumble, and you can spot us out there pretty easily. Also, we're on YouTube and on Facebook. So thank you for your subscriptions, your likes, and helping us out. If you'd like to leave a gratuity on Twitch, you can do !TIP or stream elements /Joe Slick Live /TIP. Appreciate you all. Thanks again, Canuck. Great time, and a lot of information put out there. Do you have anything you want to close with?
No, I can't think anything else because I'm running out of power and I got to go put wood in the furnace. Before I go to bed.
Run out of power. How do you run out of power? While you're on your phone?
No, I'm running out of energy.
Oh, you mean, yeah. No, your sugar levels are getting low. Yeah, I hear you. You still got to work. All right. Hey, love you, brother. Thanks so much for all that you do and your camaraderie here. And this is for you too, man. So
yeah,
I appreciate you, man. I really do. Thanks, everybody. Have a good evening, and happy belated Thanksgiving for those who follow that and the like. Love y'all. Remember,